Which micellar product is the right one for your skin? We're explaining the science, right? Yes, of course. Micellar water, micellar gel, micellar wipes, micellar pads, micellar shower gel. Is this a new technology or just a marketing scam? For everyone who asked himself the same question, I had a quick look, and everything I found was either really vague or simply wrong. Shame. Which is why it is time for this video. Hello there and welcome to my bathroom. Today we will have a look at reading the ingredients at the back of cosmetic products again. So next time you see micellar products in the supermarket or at the chemist, you can have a look for yourself and decide which ones are good and which ones aren't. Let's start with the name, micellar water. This term is from a chemistry point of view not really useful. Not really useful? That's complete bull. The moment we have soap, so surfactants, we have micelles. Micelles are nothing else but assemblies of surfactants in the water. But let's look at them in a bit more detail so you'll get all the info. And for this, we need chemistry. Yes. How surfactants work. Surfactants are molecules that look roughly like this. One part is called the head, which loves water. The head is polar and hydrophilic. The other part is called the tail, hates water, which means the tail is non-polar and hydrophobic. You can also say this a bit nicer and call it lipophilic instead. So instead of water-hating, fat-loving. Surfactants are therefore amphoteric, which means they are both water and fat-loving, even though water and fat, or oil, usually don't go well together. There is quite a bit of content out there about micelles, and more often than not, I see this chemical explanation. The surfactants bind with their hydrophilic heads on the cotton pad, and the lipophilic tails dangle on the outside and attract dirt, in this case makeup, like a magnet. But that's actually a bit rubbish. Surfactants indeed like to assemble into ordered structures, but only on a molecular level. To be precise, surfactants do two things when thrown in water. Number one, surfactants assemble on the surface of water. The hydrophilic heads look to the inside towards water and the hydrophobic tails to the outside. Through this, the interface of water and air is stabilized, which is why soap foams that nicely. Number two, surfactants assemble to micelles. Now this does not happen on the surface, but instead inside the liquid. Micelles can be spherical or cylindrical, or worm-like. The main thing to make sure is that the hydrophilic heads look towards water on the outside and the hydrophobic tails, who don't want anything to do with water, point towards the inside, as they don't like it. What they do like is dirt, gunk, makeup, fats, oils, everything that doesn't mix with water. All of this gets trapped inside the micelle and washed away with water. So all of these have surfactants in them, hence all of these contain micelles. Where it says micelles inside, there are micelles inside. Just like in any other surfactant containing product. Whatever it is that's new with this micellar technology, it's definitely not the micelles. Because micelles have been around as long as there has been soap. As I said, bull. But is there at least something new or special about these micellar products, or are we just buying the same products but under a different name? Micellar marketing, surfactant chemistry. These micellar products are marketed in the following way. Number one, they are supposed to be particularly gentle to the skin, and number two, they are supposed to clean particularly efficient. In fact, there are three different types of surfactants that are varying in how gentle and efficient they are. There are three different classes of surfactants which are commonly used in cosmetic products, particularly for facial cleaning. Dear non-chemists, here's a little warning. There are chemical formulas ahead, but you don't have to understand them in detail. I'll tell you what the important parts are. Number one, anionic surfactants. Most surfactants are anionic surfactants. Anionic stands for the negative charge on the head. Anionic surfactants are the cheapest to produce and they have the strongest cleaning effect. Anionic groups are particularly well soluble in water, so the dirt gets particularly well cleaned away with the water. But anionic groups are at the same time the most aggressive surfactants. They irritate the skin, they burn in the eyes. This has some reason in the pH. Our skin has a slightly sour pH of around 5.5. Anionic surfactants have a slightly basic pH of around 8, which contributes to the irritation. So if a product claims to be particularly mild on the skin, they shouldn't contain anionic surfactants at all or in a very small amount down at the bottom of the ingredients list, because the list of ingredients is sorted by amount. So how do you recognize anionic surfactants on the ingredients list? The by far most common anionic surfactant is this one, sodium lauryl sulfate, aka SLS. This one also exists sometimes, but it's not used as often or in such high quantities. And also all natural soaps, which are made from 100% coconut oil, 100% olive oil or avocado oil, are also 100% anionic surfactants and belong here. So anionic surfactants are the best to remove your makeup, given you have insensitive skin. Then there are cationic surfactants, which are positively charged. Advantage: their pH is slightly sour and therefore more pH skin neutral. But in turn, they are more expensive to produce and they can be harmful for the environment. They are generally not used in facial skincare products, which is why we can exclude them for now. Number 2. Non-ionic surfactants. Non-ionic means the hydrophilic groups are not charged, which is why non-ionic surfactants are particularly gentle, though they also have the weakest cleaning effect. The hydrophilic part can, for example, be a sugar molecule. You usually spot them on the ingredients list with glucoside on the end or sucrose in the name. But careful, glycerol glucoside is an exception, or not a surfactant but a moisturizer instead, as glycerine is not a long fat group but a small molecule instead. The hydrophilic part can also look like this. This group is called PEG and you'll find it in the ingredients list accordingly. PEG surfactants are, however, controversial, as during the synthesis, so formation, smaller PEG chains form which can penetrate the skin and can be harmful. And then there are poloxamer surfactants. They are the most gentle surfactants but also have the weakest cleaning power. Without being a chemist, you can see from the first look that the hydrophobic part and the hydrophilic part look very similar at poloxamers. The polarity difference is not very big, which is why they are not the strongest surfactants. So, non-ionic surfactants are very gentle, suitable for sensitive skin. However, they also don't remove makeup as efficiently as anionic surfactants and should therefore come relatively early at the beginning of the ingredients list, as there would be a lot of them needed to clean efficiently. Now, there's also the golden middle. Number 3. Amphoteric surfactants. Amphoteric surfactants also count to the ionic surfactants. The hydrophilic group is therefore also charged. However, the charge can be positive or negative depending on the pH. Amphoteric surfactants are clearly gentler than anionic surfactants. They don't burn in the eyes and are therefore used, for example, in baby shampoos. They do also have a good cleaning power, however don't quite hold up to the anionic ones, but it is already pretty good. In return, amphoteric surfactants are the most expensive to produce. There are 2 keywords with which you can recognize amphoteric surfactants in the ingredients list. One is ampho and the other one is betaine. These are, from a chemistry point of view, the best surfactants, gentle and efficient. I've put this little summary together for you, so you can take a screenshot of this list and look it up next time you go to the supermarket. So, with this knowledge, you can already judge for yourself which surfactants, so which micelles, should be in micellar products to be both gentle and efficient. Namely, amphoteric surfactants or large amounts of non-ionic surfactants, possibly in combination with small amounts of anionic surfactants. Now, let's compare from the same brand the normal products with the micellar products. Here, both products contain the same surfactant, at least an amphoteric surfactant, so a good surfactant. And I gotta say, the ingredients list for the micellar product is clearly shorter, which can be an advantage for sensitive skin. And here, the normal product contains actually better surfactants than the micellar product, if you want to say it that way. It has more amphoteric surfactants. Conclusion: the new thing about micellar technology are not the micelles and also not the ingredients, but above all, the marketing. How good are your surfactants at home? Did you pick good products? Check it on the ingredients list at home and put it in the comments below. Do you have any more topic suggestions? Put it in the comments as well. And I'll see you again in 2 weeks for the next video. Until then, as always, stay sciencey.